Hi there and welcome Grade 11 Mindsets. It's finally is your turn, and as you can see, I've got a comedian slash teacher. Peter is back in action. We've missed you, Pete.
Oh, I don't know why you've missed me. I've missed you. You haven't been around for, 5, 6, 7 months now. It's
No,
been
I
quite a
have.
while.
I have, guys. They'll tell you that I have been here. That
Really?
You've just been missing me, like
When
different
you are, I'm
days.
off, and when I'm
Yeah,
off, you're-
exactly,
I can
exactly.
understand that, but I'm sure the viewers understand why we do this.
Yeah.
All
yeah.
right. Great week for you.
Brilliant week for me.
Enjoying the Olympics.
Loving the Olympics. I
Fantastic.
love the
So far,
Olympics.
5 medals as we talk today, which is absolutely exciting. Great weather on Tuesday.
Snowing.
And
Hey.
apparently, history has it, it's the first time it snowed on the same day in every province.
Really?
Yeah,
Not
can
even,
you believe it?
Not even in 1961. When was
Well,
the
I
last
don't know
time it
when they ever
snowed?
recorded it. I don't know, but apparently
Hey.
that's what I've heard.
Incredible. How many of you guys saw the snow? Let us know.
Let us know. I'm going there.
No,
You
but
tell
what
them
you're
about
going to
this.
do, you're going to tell them first what we're going over. So it's 2D and 3D measurements.
It is
All
indeed.
very
And guys,
exciting.
here's the great, exciting thing. We're only doing one question today. That's given our producer quite a fright.
Is that
She's got
exciting?
ads ready because she doesn't know what's in store for us today. But guys, one question today, but it's a phenomenal question. In fact, it's a portfolio piece that I gave my grade 11s earlier this year. So it's well worth having a look at. I think it's great because
So
it
that
involves
sounds
so many
mean.
things.
That sounds like a mean question.
I know, especially when you walk into your class and you say to your students, you only got one question to do today. But it's
for
got
an hour,
like
for
30
an hour,
points. Yeah,
Hey?
parts to it.
An hour lesson. Oh,
I'm going.
Guys, it's going to be amazing. I'm telling you, we're going to have such fun. So what you need to do is you need to chat to me, Indiana, on Facebook, facebook.com/Learn Extra. You can also chat to me on Twitter @Learn Extra. If there's anything that you are struggling with, please post it on the page so we can help you in the last 15 minutes of the show. So now I'm going to pass it over to Peter, and we're going to have an awesome lesson. I'm pretty excited. Pete, take it away.
All right, folks. So it's 2D and 3D measurements. All right. So this is the task that was given to my students earlier this year. Quite simply, your school wants to build a swimming pool. And we are going to find out how much it actually cost us to dig the hole, to get the soil out of that hole, obviously, right? I suppose you've got to get the soil out, otherwise it's not a hole, is it? Yeah. Okay, so we got a ground. We're going to dig in. We're going to pull out some soil, and so we're going to be left with the hole. We've got to get rid of that soil. Then we've got this lovely big hole. We've got to line it with some concrete, right? And then we've got to fill it with water. The question is going to be ultimately, how much does this project cost us? So let's have a look at the question straight away. Okay. Now, a school is to build a swimming pool with these dimensions: 25 meters long, 10 meters wide, 1.5 meters deep on average. Let's just stop there for a minute. Now, obviously, you're aware that sometimes a swimming pool doesn't have an equal depth throughout, right? You might have a pool that's got a shallow side, and then it's got a deep side. But on average, we're saying that the depth is 1.5 meters deep. Do we understand that? Okay, let me draw it for you here. So let's pretend that we've got a pool like that. Can you see that? So this part might be 1 meter deep, and this part here might be 2 meters deep, but the average depth is round about 1.5 meters. Do we understand that? So I've actually made the question kind of easy, because now you're not trying to work with a weird looking shaped pool, but you're going to pretend it's a rectangular pool. Okay? So it's got a depth of 1.5 meters, even though it doesn't. Some's 1 meter, some's 2 meter, but on average, 1.5 meters. Now, the following information is also going to be useful to us. No heavy machinery can be taken to the site, so everything has to be done by hand. The density of the soil at the school is 1.6 grams per centimeters cubed. The volume of the soil that can be put into a wheelbarrow is 0.8 meters cubed. A worker can fill and move 12 wheelbarrows per hour. A skip can hold 9,2 meters cubed of soil. They cost 1,750 Rand per day to hire. What's a skip, folk? A skip is one of those huge metal containers. And you can just throw a whole lot of rubbish inside there. Okay, in this case, we're not throwing rubbish. We're going to be throwing soil inside that skip. All right, so you all know what a skip is, hey? That big metal container. Normally, they get picked up and put on the back of a truck, and the truck takes the container off. Got that? And that costs us 1,750 Rand per day to hire. We're told there are 2 workers who each work for 6 hours per day at a cost of 200 Rand each. A local businesswoman has donated the pump and filtration system worth 12,500 Rand. Sure, that is a lot of information that's just been given to you. A whack of information. Now, let me just tell you this. If you were given this kind of question in an exam, whether it's at the end of the year, whether it's a class test, even if it's at the end of the year, they wouldn't just pump all this information on one sheet. Normally what the examiner would do is he would ask a question and then give the information that you require for that, and then you're able to answer it. Then he'll ask you another question, give you a bit more information, and then you could answer that question as well. But that's all the information we need. Now, let's get on with our very first question. So, question number 1 states the following. How much soil will there be in meters cubed? So, there's a bit of information that we need. And we need the following information. Okay? We need to know the actual length, the breadth, and the height of that hole. Because once we know the length, the breadth, and the height of the hole, we'll be able to determine how much soil is actually in that hole. Right, so if you remember correctly then, how do we know the volume of a rectangle? We are going to say that the volume is equal to length times the breadth times my height. Now, what is my length? What's my breadth? What's my height? Let's go back to all that information. We can say we've got a length of 25 meters. We have a width of 10. So let's write that down straight away. We've got a length of 25 meters, a breadth of, what did we say, 10 meters, and an average height of 1,5 meters. Let's just confirm that. So we're saying 25 and 10, 25, 10, and 1,5. Absolutely excellent. All right, so now, we're dealing with volume, guys. I know if I'm dealing with volume, my units at the end have to be units cubed. If I was dealing in area, it would be units squared. And if I was just dealing with perimeter, I would have just plain units, like meters. Area, meters squared. Volume, meters cubed. And we're dealing in volume. So we know it's going to be meters cubed. And so it's not a bad thing to write here already, meters cubed. So before I've even solved the problem, before I've even pushed buttons on a calculator, I know my answer is going to be meters cubed. So out comes our calculator. And we're going to say, right, 25 multiplied by 10 multiplied by 1.5. And we get an answer then of 375. So 375 meters cubed. Right, now every single week I sit here or stand here and work, and Indiana just sits and types away on a computer.
I pretty much have fun. I get to chat to everyone, and I get to be social, and you get to teach. It's important. You need to teach.
What she's trying to say, she does nothing. So, this question is going to require me to keep getting information from previous questions. So, Indiana, I need you to type this kind of thing down.
I see where this is going,
okay,
Peter.
You see where this is going. Get out a Word document and let's go for it. The volume, 375. Got that?
Mm-hmm.
Sure, we're making progress. Right, let's go on to our next question.
Hard work this, yeah, Peter.
Our next question. How many wheelbarrows worth of soil is that? All right, so now we've got to know if I have a volume of 375 meters cubed, okay? So we know then that my volume, let's get a nice color pen, my volume is going to be 375. Is that right, Indiana?
That is absolutely correct.
Cool.
Well done.
And we know as well that when I go back and have a look here, one wheelbarrow is, what did it say? The volume of soil that can be put in a wheelbarrow is 0.8. So I know that each wheelbarrow is 0.8 meters cubed. So if I divide this by 0.8 meters cubed, it's going to tell me how many wheelbarrows I need. Let's go through that again. All the soil comes to 375 meters cubed. I need to take a little bit out and put it in the wheelbarrow. How much do I need to take out? Well, I can only take out 0.8 meter cubed worth of soil. Put it in the wheelbarrow, okay? And off you go with the wheelbarrow, pushing it away. Then you come back, you see, and you get another wheelbarrow, and you put in another 0.8 meter cubed of soil, and you push the wheelbarrow, and off you go. And then you come back, you see, I haven't gone away, I'm back, and you come back and you put more. Now, how many times do we have to carry this wheelbarrow? Well, I've got 375 meters cubed, taking out 0.8 meters cubed. Let's see how many we need. So all I'm going to say then on my calculator is this. 375 divided by 0.8 equals, and we land up, now I want us to take notice of this, 468,75. 468.75. 468.75 what? Wheelbarrows. Okay. Now, gentlemen, you can't take 0.75 of a wheelbarrow, okay? You can fill up a wheelbarrow 3/4 full, but you can't take 3/4 of a wheelbarrow. So I can't have my wheelbarrow and say, right, I'm only going to take a little bit of this wheelbarrow, so I'm going to cut off 1/4 of it, pick up the back part, and off I go. That's just totally stupid. I've got to take the whole wheelbarrow. And so what I'm saying is this, instead of 468, I'm going to take 469 wheelbarrows. Got that? Easy? I hope so. Producer was saying something in my ear. Was she calling for an air break? Was she?
Okay, I don't know.
Oh,
No, she wasn't. She wasn't.
Okay, nice. All right, let's move on. So, now, what is the mass of the soil in kilograms? You may use the following formula. The mass is equal to the density times the volume. Now, take note here, folk. They're actually giving us a formula. And remember what I've always said. Now, we say this to the grade 10s. We're saying it to you now, the grade 11s. And let me break some good news to you. Next year, when you're in grade 12, we're going to be saying the same thing to you as well. If you get given a formula, use it. Right? There's no point in an examiner giving you formulas if you're not going to use them. So, I see a formula and I say to myself, I must use this formula. And that's what we're going to do. So I know the mass, and we asked to calculate that mass, and there it is there, is equal to the density. Wait, what's the density? Are we given the density at all? Yes, we are. If we go right back to our bit of information that was given to us earlier. In fact, I've got it on another sheet here. Here we go. How good is this? Right. So, if we go right back, we get told that the density of the soil is 1,6 grams. Let's have a look at it. 1,6 grams per centimeter cubed. Okay? 1.6 grams per centimeter cubed. Now, let's go to our formula. And our formula density, and we said it's going to be 1 comma, let's get a
6
pen.
grams
1,6 grams per
centimeter cubed.
centimeter cubed. Good. Times the volume. Now, times the volume of what? Times the volume of soil. Now, Indiana,
I'm scared,
your
yes.
answer was, remember we worked out
Of
the
soil.
volume?
Oh my gosh.
300 and?
Wasn't it 469 wheelbarrows?
No, not the wheelbarrows, the density of the soil. Okay,
Oh, no, go
remember, it
back,
was
Peter.
375 centimeters.
Ah.
Okay, do you remember that?
I understand. Yes, I
Okay,
remember
in fact,
that.
it wasn't centimeters. It was 375 meters cubed.
Cubed.
Oops, there we go. Where's my pen gone? Okay, meters cubed. I have a huge problem here, gentlemen and ladies.
Yes, don't
And
forget the
that's this.
ladies, especially it's Women's Day. Peter, you better, thin line.
It is Women's
It
Day.
is?
This is why we've had a wonderful holiday today.
Oh no!
I
Thank goodness
know.
for women.
All right. So, ladies and gentlemen, the problem we have is this, that we are dealing with centimeters cubed over here. Let me get another color so you can actually see this. Centimeters cubed here, but here we got meters cubed. Now, we've got a problem. We've got to get the units to be the same. So I'm going to have the density in meters cubed and the volume in meters cubed. Or I'm going to have the density in centimeters cubed, but then the volume also has to be centimeters cubed. Okay? They have to be the same. And let me show you why. What we're going to have is this. If I have grams, now do you know what the slash means? In other words, for that slash is per. So it's 1,6 grams per centimeter cubed. In other words, if I got a little box and it was 1 centimeter high, 1 centimeter long, and 1 centimeter wide, tiny little box, and I filled it with soil, that soil would weigh 1,6 grams. Sure, tiny little bit of soil. But we're not dealing with tiny little centimeters of soil. We're dealing with meters of soil, right? So if I've got an area a meter wide, a meter long, and a meter high, what's the weight of that soil? So what we're going to do is say, you know what? Let's change all our units to the same thing. So if I'm measuring what's the weight in a meter, then we need to change that to meters. Or if I'm going to keep it centimeters, we got to change my meters cubed to centimeters. And that's exactly what I'm going to do here. So I'm going to say I've got 1,6 grams per centimeter cubed. Now I'm going to change this 375 to centimeters. Okay? Now, how do we change meters into centimeters? Well, how many centimeters are in a meter? There are 100. Agreed? But because I'm cubing, it means I've got 100 this way, 100 this way, and 100 extra this way, or 100 times more in my height as well. So it's 100 times more in my length, 100 times more in my breadth, and 100 times more in my height, because it's volume. So I'm going to say it's equal to 375 times. There are 100 centimeters in a meter. But we're not just dealing with centimeters and meters, we're dealing cubed. And cube means I've got 3 of these things. Okay, because it's got 100 times more in the length, 100 times more in the breadth, and 100 times more in the height. And that will now be centimeters cubed. Equals. So now what have I got? 1,6 grams per centimeter cubed multiplied by. Now let's bring out our calculator and have a look. With my calculator, we're going to say, cool, I've got 1.6. Let's try that again. Oopsie. Okay. Okay, calculator has frozen on us. Why does a calculator have to freeze on us?
Oh,
Why do you
shame,
think it
Peter.
happens?
Shame.
I
What
think
we-
maybe that's a gremlin saying we need to take an
Exactly.
ad break.
Exactly. So can I take it to ad break?
Let's take it
You
to
see
ad
how
break
he
and
likes
I'll
to
fix
do
up
my
the
job.
calculator
He
for
likes to do my job. I'll let him do his job. Guys, we're going to take a quick break. See you now.